Okay, so I just looked carelessly, which I can be relied on to do. I got E2 equals 1 equals, so I just went down here, right? That's not E2 equals E1. That's a product of the E2, E1 matrix by the original matrix, which equals this matrix, right? So I shouldn't have this here. Okay. So let's get the right matrix in here. The E2, E1 matrix is 1/2, 0, -3, 1. Now it's going to work. I'm confident. Well, at least the 2, 0 times 1/2, -3 does give us 1. First row times second column, zeros match up, gives us 0. Second row times first column gives us 6 and -3.
I think 12 is supposed to be a 6.
Yeah, somebody was saying that. Okay, let's pretend it is, and then we'll see why. Must have copied something down wrong, or just did, you know, very, very possible. And I multiplied it. I did it wrong. If that's a 6, then of course we get 0, because half of 6 is 3, -3 gives us 0. And then 6, 1 times 0, 1 gives us 1, so it works. Okay? So we're just verifying all the aspects of this problem. Now, how did I not have a 6 there? Because I multiplied this. Oh, it's E1 inverse times E2, 0, 1. Yeah, 0, 1 times 1, 6 is 6, not 12. Okay? So, did that wrong. Okay, so correcting the errors, as we often have to do, especially me. We verify that everything kind of comes full circle, right? Okay? Now, we could have verified that E1 inverse E2 inverse times E2 E1 equals I without having to write out any matrices, because matrix multiplication is associative. Okay? Now, kind of abusing the associative law a little bit, but it works as well here as it does with numbers. And we did this last time, but I'm doing it again. I'm writing it out in detail because I didn't write it out in detail before. Okay? So we have this. So that equals E1 inverse times I times E1. Right? And I can group that any way I want, so I'll just group it like this. What's I times E1? Okay, so that equals E1 inverse times E1. What's that equal?
I.
It equals the identity. So if I've got the inverses right, it has to work. If you accept the associative law. You don't have to use a commutative law. Nothing has to change order, which is a good thing, because in matrices you can't do that. Okay? So there we have it. And if it, you know, if this is a bigger matrix and we had an E1 through E40, okay? Well, we do E1 inverse down through E40 inverse, right? So if we have E40 down through E1, we'd be multiplying that by E1 inverse through E40. E40 would match up with E40 inverse and would essentially disappear if you can accept it by this process. This thing disappears, right? And they disappear one at a time, and in 40 steps you'd be back to the identity. So you don't really have to write it out. Okay? But you do have to know that that's how you symbolize it, because you've got to prove something. That's what you want to do. Okay?